Hello, everyone. Thank you so much for being here. My name is Nick. I'm the founder of Understanding Behavior, your newest cool place for test prep content. And I'm really excited tonight. We have a very special Zoom for us. We are going to be going over experimental designs, which I know is a struggle topic for a lot of people. It's one of those topics that it's just not very intuitive. It's hard to get a good grasp of it. It's very abstract, a little bit mathematical even. So it can be really difficult for students, but no fear because Nick is here and we're gonna crush this today. Just a quick plug before we get into our main event here tonight. I also do offer tutoring services, so if you are interested in one-on-one tutoring, if you feel like you need a little bit extra push in your studying game, feel free to check out understandingbehavior.shop where you can check out all of my packages. Also, if you haven't taken this yet, at the bottom of my shop there is a spot where you can subscribe to emails, and if you do so, you'll instantly receive a 25-question mini mock. Full mock is on the way, but this hopefully this will get you through a little bit. Anyway, let's hop into our main event here tonight. I'm curious, where's everybody tuning in from tonight? I live in Denver, Colorado. It's a very cool place. We're starting to get some fall weather here. It's been pretty nice. But where are you guys from? Cool. Carrie from New Jersey. Kat from Arkansas. Sweet. Lenny from PA. Rasa from all the way from Lithuania. Awesome. Welcome. Cool. Faiza from Georgia. Natalie's from Kansas City. Cool. Lenny from Abington. Awesome. Very cool. Thank you guys so much. It's great to see people from all over the country and even the globe here. Super cool. Let's go ahead and let's just hop into experimental design. We've got a lot to cover tonight. So I wrote out these notes. These notes, I think, give us a nice little summary of everything we need to know about experimental design. There are some points in here where I've actually blocked off some of the words. So at those opportunities, I'm going to ask you guys what we should be putting in there. Sweet, we got some people from Florida too, Kevin and Anna Maria. Sweet, Maria from Cali, Rosanna from NYC, Jessica too from Florida. Very cool. Awesome. Well, welcome guys. Thank you so much for being here. Let's go ahead. We're going to jump right in. So before we hop into all of our different experimental designs, what we're going to do is talk about the purpose of an experiment. So here's the main purpose. What we're trying to do is demonstrate the effect of a single independent variable on the dependent variable. And a simpler way we can put this is, how does this treatment or variable impact the behavior? And when we're designing our experiments, we need to make them in a way where we can actually see the effects of a single independent variable. So usually we're doing that by comparing two different conditions. One is just the condition that we have, and then the intervention or treatment condition is usually the same exact thing, but we're adding that one variable. So it allows us to compare those two different things to see if this independent variable has that impact on the dependent variable. So our independent variable, that is the thing that is being manipulated in the experiment. We can think about that as a treatment or any change that might potentially affect the behavior. So what's our common layman's term for our dependent variable then? This is going to be our first active student responding here. What do you think is behind here? What's if our independent variable is our treatment, what is the dependent variable? Nice. You guys are killing it. Amanda, great to see you here. Maria's killing it. Ross is killing it. Good. Tasia, Carrie, Lynn. Excellent. Lots of people on it. So excellent. This first blank here is going to be our behavior. So again, we're looking at how does this treatment affect our behavior is our main thing in all of our different experiments. So I hinted at this earlier. So when we're talking about an experimental design, this is a way that we can set up our conditions that make sense to see this effect of an IV on a DV. This should actually be effect, not affect. So we want to make sure that we're just changing one thing between our conditions to see if this has an effect. And then experimental control is another important term that we're going to be talking about a lot today. And this is essentially the confidence that your independent variable has a clear and consistent effect on the dependent variable. So you may have heard of the term internal validity before. That's basically like how tightly controlled your experiment is. And it also refers to things like choosing the correct experimental design for your option, which is another thing that we're going to cover pretty extensively today. So experimental control is that we are very confident that this behavior, or that this independent variable, this treatment, is having this clear and consistent effect on our dependent variable. All right, so we've got another blank here. Next up, we're going to compare single subject designs versus our group designs. Now, in behavior analysis, we mostly use single subject designs, and that means that the entire experiment is conducted with, this is actually a 2-word answer. Let's see if you guys can get this, but 2-word answer here. And think about, like, does a single subject design mean we can only have one subject? What do you guys think? Any ideas on what is behind this this blank spot here? So think about, like, are we doing our experiment with just one subject here, or what if we have multiple subjects? Does that automatically mean it's a group design? What do you guys think? Any takers? I know, kind of a trickier one. Yeah, so we're looking at what is behind this blank here for single subject design. Good. I like where you guys are going here. Yeah, Amanda's saying that we usually have like up to 5 for single subject designs. It's not really a hard number, but typically we don't have that many more than 5. Good. Yeah, Dora, I like where you're going there with your answer. Jessica as well, looking good. So this one is going to be with each subject. So we can have multiple subjects in a single subject design, but we're going to run the entire experiment with each of them. So, and comparing that to a group design, this is where we have a very large number of participants. They're split up into 2 groups. One receives the treatment, and the other receives either a placebo or that current best practice treatment. And then we use statistics to compare the two. But in single subject designs, we use the subject's own behavior as the control for comparison. So if we're looking at like this withdrawal graph, for example, the individual's behavior is what we're tracking throughout this whole entire experiment, no matter what the phase is. So for single subject design, it means with each subject. So it doesn't only mean one subject, just means that we're doing the whole experiment with every subject. Good. Yeah, Lenny PP is asking a great question here. What is the difference between within subjects and between subjects? Excellent question. Those are actually replacement words that we could use for single subject versus group design. So this, our single subject design would be our within subjects. So think about the whole experiment is like within this one subject. And then our group design is between our subjects. So those are just AKA terms. Feel free to replace those as ever you feel needed. Good. All right. Last thing I want to talk about before we get into our individual design. So this is prediction, verification, and replication. We'll go over this more in our withdrawal design too. So we'll go kind of fast for now, and then it'll make more sense later. So prediction is that we can predict that the trend will continue if we were to continue that phase. So actually, I'm going to pop over to this withdrawal graph real quick. So here's just an example. We have a fairly stable trend here in our baseline data. Oh, that's like a rainbow pen. That's weird. Let's use a solid color pen. So here's going to be our trend line. And we're going to predict that if we were to continue running baseline, that the trend is going to be about the same. So we might see data points kind of like this, and our trend is going to be very similar from our baseline levels. That's what a prediction is. We can also make a prediction about our intervention condition. So same thing here. We could predict that if we were to continue our intervention phase, that we're probably going to see no behavior. I didn't want a shape there. There we go. We can take that off. So that's going to be our next prediction. So these blue lines are going to be our predictions. And we can make a prediction about any phase. Next, let's go over our verification. This shows that the trend of the behavior reverses when going back to the original condition. So sometimes I like to, instead of labeling like A, B, A, B, so, sometimes I enjoy labeling these conditions 1, 2, 3, 4. And the reason for that is because we always see verification in this third phase where we've replicated the results of our initial baseline condition. So what we had here is that we had stable high level behavior in our original baseline. We predicted that it was going to stay stable high level behavior. And then when we actually reversed to that condition, that's when we saw that the pattern did continue. We had this stable high-level behavior. And once that is demonstrated, that's when we say verification occurred. And when verification occurs, that's when we can say that we have experimental control. So once we do this reversal back to our original condition, we are confident that, yes, this independent variable has a clear and consistent effect on this dependent variable. Because when I put it in, the behavior greatly decreased. And when I took that variable out and didn't change anything else, I saw that behavior increase very significantly. So I'm very confident that, yep, that was the thing that did it. If we didn't do this reversal, there's a potential that there could have been two different variables that changed in B. And we don't know which one of those things would have actually caused a behavior change. But when we can isolate it like this and prove verification, now we're confident we have experimental control and that this independent variable goes back to our purpose, that we have demonstrated that it has a clear effect on our dependent variable. Which, again, is the whole reason why we're doing this. And then lastly, replication is what happens in this phase 4, or whenever we revert back to a later intervention phase. So in this one, we made the prediction about our, hold on, let me scooch this over for you guys. But in our first B phase, our condition 2, we made a prediction that if we were to stay in B, that we'd have 0 rates of behavior. And when we went back to B, we saw the same thing. We saw 0 rates of behavior. So in this phase is what we call replication. We've replicated the results of this intervention being the same thing. And this is kind of just like we're flexing on experimental control, but also we are putting this in because it's kind of assumed here that we wanted to decrease that behavior because that's what the intervention did. Okay, so we kind of talked a little bit about the withdrawal design already, but let's go ahead and talk about some of the features here. So we can have an AB-AB, which is what we just reviewed here. This is we reverse between baseline and treatment conditions after we see stable data in a phase. There is one exception to that we'll go over in a little bit. Within withdrawal design, you are also able to start with our intervention. We could do something like a BAB. This is the strongest demonstration of experimental control out of all 4 of our designs because we show these very clear relationships with and without this independent variable and how that affects the dependent variable. All right, we've got another blank here. So when we're talking about our A condition, what does that refer to? Let's see that in chat. Yeah, so Jessica's asking, prediction when we're observing that two events occur together. So we're thinking about prediction with experimental design. We want to basically continue the trend of the previous condition. So we saw the trend of A, and then we predicted that if we were to stay in A, that we would see that same trend and same level or so. Awesome. Excellent answers in chat. Way to go. Kat, Rasa, Faiza, Dora, looking great. Kevin, too. Lots of you guys here. Awesome. So this one is our baseline condition. And then when we go to our B phase, that's going to be our different treatment conditions. So these can be different letters too. If we have C, that's usually going to be like our intervention 2 or treatment 2. So just be mindful of what that means when you see letters B and beyond. Awesome. Wow, we have 35 people here. That is so cool. I think this is actually the most popular stream that we have ever had. Thank you guys so much for showing up and being here. Love all the participation. Let's keep going. Okay, so we talked about when to phase change. So we talked about our first pattern. That was the pattern that we saw up in here in our withdrawal graph. What is behind this blank? That pattern that we that signals that we could phase change here. Yeah, Kevin, I love how you're like helping to teach other students in chat too. I always tell people that if you're able to teach somebody else these materials, that is the best demonstration of fluency. So I highly recommend that whenever you can to get the most out of these sessions, especially if you're like, yeah, I got this, but like I want to solidify it. That's really cool. Nice. Answers coming in are awesome. Rasa Faiza. Good. Maria, Jessica, right on track. Natalie, great. Carrie Lynn, great. This is going to be our stable data. Okay. So there's also one more way that we can phase change other than stable data. I'm going to draw two different data paths and see what you guys think. So we're looking at a problem behavior here. This is a behavior targeted for decrease because we see high rates in baseline and low rates in intervention. So I'm going to draw two different patterns of baseline data. This is going to be our first one. We have an ascending trend. And then I'm also going to draw a blue one. Let's say we have a descending trend that kind of looks like this. All right, what do you guys think? So one of these I'm able to phase change, and one of these I'm not able to phase change. So is it the blue one that's descending that, we're going to answer which one can we phase change on? So is it the green one that's ascending, or is it the blue one that's descending? Throw your answers into chat. What do you guys think? Which one of these trends can we phase change on? Blue or green? If you have a rationale, that's like how to separate yourself from the pack and be like really cool. So this is, again, a behavior targeted for decrease. So yeah, just to repeat the question, we have this blue trend that is descending. We have a green trend that is ascending. One of these, when we're dealing with problem behavior, we are able to phase change with. Is it the blue or green, and why is the question? So again, this is a behavior targeted for decrease. All of these situations, we're targeting the behavior for decrease. Ooh, Natalie, I like where you're going with your rationale there. All right, little mixed bag here, but it looks like most of y'all got it. We can phase change on the green here. So I can, I'll say PC, green, PC for phase change. Sorry, my handwriting's even worse on a computer. That is not a P. All right, so we can phase change. That's not an N either. But we can phase change on green here. Hopefully that's clear enough. So let's go ahead and back to our notes and see what this is like. So we can also phase change if the behavior is trending in the opposite direction intended by the next phase. So in this one, since it's a behavior targeted for decrease, we are expecting, if our intervention is going to work, that we're going to see a decrease in the behavior of this phase. So with ascending data, it's like the problem is getting worse, so we can still show experimental control. One other rule I want to throw down here, really important one. I'm actually going to like bold highlight it. I don't know how I didn't make it on here before. But this rule is that trending data are likely to continue to trend. So now, here's the other half of that rule, and hopefully it makes enough sense. We cannot phase change if the behavior is trending in the same direction intended by the next phase. Let's look at why. So looking at this blue line, the behavior, again, this is a behavior targeted for decrease. Let me actually put that here too so you guys remember when you're looking at these notes on your own. So in this one, there's if we were to phase change here, if we had this blue line of data, if we were to phase change here, there's actually two things that could explain why the behavior is decreasing in phase 2. So it could be because of our intervention, or it could be because the data are already trending downward. So now that there's two possible explanations for a decrease in behavior, I don't have experimental control. I have no idea if my thing was the thing to change the behavior, or was it this trend? Like it was already going to go down on its own. We have no idea, and we ruin the purpose of our experiment there. We can't demonstrate the effect of a single independent variable anymore because we've changed two independent variables at the same time that are likely to change this behavior in this direction. So when we have the data is trending in the same direction as intended for the next phase, we cannot phase change. But if it's trending in the opposite direction, then it's like even stronger. It's like, oh, sweet, we totally flipped the direction of this as well, in addition to changing the level of this behavior very significantly. Awesome. Hopefully that makes sense. It's definitely a confusing concept, but something to look out for. All right, so we are wrapping up our withdrawal reversal designs. Last thing we'll talk about with these is our utility behind them. So I think it's really important to understand why and when we would use each of our designs. So let's go ahead and look at when we would use that. First of all, we cannot use a withdrawal or reversal design for behaviors that cannot be reversed or unlearned. So let me show you like what would happen if we were to do that. So let's actually do this on a different graph. If we were to do a learned behavior. So in our baseline phase, they expectedly would not know the behavior. In our intervention phase, they might learn the behavior very quickly. So something like that. But when we reverse back to our baseline phase, they're actually not going to forget it. They still know how to do the behavior. So looking at this graph, what did we fail to create? That was the big problem. Was it do we fail to create a prediction, verification, or replication? So again, looking at this graph with a learned behavior, when we revert back to baseline, what did we fail to do? Did we fail to create predictions, verifications, or replications? Which one hurt the most? So they didn't know it in baseline, we taught the behavior, and then we went back to baseline and it didn't go down. They still know it. All right. Couple people on the right track here, looking good. So Miss TJ, Amanda, Kevin, Flavian, Maria. Excellent. We failed to have verification. So we could still make our predictions. We can make our prediction about our baseline condition that hopefully it'll go down. But we didn't replicate that, the results of that prediction. So this one has no verification, which means that we also have no experimental control. So this is an example of choosing the wrong design for a situation. There's no way that we can show experimental control for this kind of behavior. So we just wouldn't use this design. So no experimental control for learned behavior. So you guys have that label here too. Cool. So hopefully that makes sense. Let's talk about our other utilities. So there are potential ethical limitations with blank or blank kind of behavior. What should go behind these boxes? We're seeing ethical limitation with a withdrawal design. Cool, Maria's on the right track. So SIB might be an example of these kind of behaviors, but it's not the label that we're going to use. Good. Awesome. Lots of great answers. Keep it up, everyone. And even if you're not getting these answers right, I highly recommend that you still try these questions just so you can learn and get that feedback too. Because when you respond and actually experience the consequences of your behavior, you learn better. So excellent. Really nice job here, Maria, Kevin, Amanda, and Lenny here too. So this is going to be our severe or dangerous behaviors. So severe behavior, that's going to be behavior of concern that is very high intensity, high in magnitude, could potentially hurt somebody, or dangerous behavior, which has high risk of injuring the client themselves or injuring other staff members. Good. And then, as we mentioned earlier, you also can use multiple interventions in this design. So that example would be like an ABAC design. All right. How are you guys feeling on withdrawal reversal designs? Does anybody have any questions? Anything that you might want to review again on this graph? Let me know. I'll open the floor for a minute or two, or we'll say like 30 seconds to a minute or so. If you guys have any final questions on reversal designs, these are probably the ones that you are most familiar with, hopefully. And so, but hopefully we kind of expanded your knowledge about these, because when you look at them, they look simple, but they can get pretty complex. Good. Thanks for that feedback, Amanda. Glad you're enjoying the session. Sweet. Yeah, so Kevin's asking, BAB, what's a disadvantage of a BAB? So first of all, like you won't necessarily have that initial baseline data. If you might have some like pre-intervention baseline data that you'd have, but usually that's a disadvantage that you don't have it as clear. Another disadvantage of it is that it's kind of a slower way to process interventions. So we'll talk about that more with the alternating treatments design, which is kind of like the fix for that. And then lastly, there can be some ethical limitations as well, and that's just kind of the nature of the design. Sometimes, like if we do a BAB, we'll go to A for literally one data point to prevent any damage happening to the client or others. But even then, that can be an ethical limitation, especially if it's if like the behavior is severe enough that to potentially like hospitalize somebody. Okay. All right, sweet. Well, glad you guys are digging the session so far. Great discussion and participation so far. Let's keep it up. Next, we're going to talk about the alternating treatments design. Another term for this is the multi-element design. So if you ever see those terms, they are exactly the same. Okay, so really important thing. There's one feature about the alternating treatment designs that is the most crucial, but a lot of people go to something else first. So what should be behind this first box? We're blank alternating between our conditions. What do you guys think? So fill in the blank here. Blank alternating between our conditions. Ooh, we got some smarties in the house. Anybody else got it? Killing it. Nice job, Dora, Kevin, Maria. This one is going to be rapidly alternating between our conditions. Excellent. So what we mean by rapidly alternating, here's a little graph example, is essentially every session we're switching what condition we're doing. So in this one, we only have two conditions, but we're rapidly alternating between them. So first one, we do the forward and warm, then the back and cool. Session 3, we go back to forward and warm, back to back and cool. You can actually see it right here. We did 2 data points of the back and cool. That's just to kind of control for what we call a sequence effect. So if they kind of learn the pattern that like, hey, every other session we're switching it up, then to make that not a variable is that sometimes we would do sessions that are 2 in a row. So that's another way to boost up your internal validity and making your experiment a little bit tighter is by adding sometimes these double sessions and not always have it just be the same pattern of rotation or the same back and forth kind of patterns. So rapidly alternating between our conditions is the most crucial. Another feature of the alternating treatments design is that you don't have to do a baseline condition. So in this one, we had no baseline at all. Sometimes you'll see a control condition that is also alternated between. So we have a special procedure that we usually do that in, but that's actually our next blank here. So this one is going to be a clinical procedure or a clinical assessment that always uses an alternating treatment design. What is that? What is behind this blank here? What do you guys think? Good, I love it. Excellent here, crew. Lots of great answers. Denise, Kevin, Amanda, Flavian, great. So this one is going to be our functional analysis. Whenever you see a functional analysis, you can 99.9% of the time be like, yep, that's an alternating treatments design, or at least that's one component of the design. So you might have something a little fancier like an alternating treatments with the reversal, but it's always going to be a function, an alternating treatments design for a functional analysis. Pretty surefire thing. Just to like give you an idea of like how surefire that is, I did a review of over 100 articles that did functional analyses. There was one of them that did a withdrawal design, but it was after they failed to get conclusive results from their alternating treatments design. So it's a really, really surefire thing. If you see functional analysis, just go right to alternating treatments. Okay. So how do we tell if there is experimental control? We are going to compare something between the conditions. I'll give you a few options here to think of. Are we going to compare the level, the trend, or the variability of between the conditions to see if we have experimental control? Yes, if you go to the, let me actually repost that link for the form. If you guys do want to get the notes after this session, make sure you fill this form out. Kevin's asking, what's the difference between sequential alternating treatment design and alternating treatment design? I don't think that's something you're going to be asked about. I've honestly never heard that term, sequential alternating treatment design. If I were to try to like put my logic to it, what I think it is that it's like you're going to always alternate in a sequence. So it always might be like back, forth, or condition 1, 2, 3, 1, 2, 3, 1, 2, 3. That would be my guess. But I don't think that's a really important differentiation to pay attention to. Good. Is it Raza or Reza? Absolutely killing it there. Yeah, Denise, Amanda, good. Yeah, Natalie, I like where you're going. Perfect. So this is going to be a comparison of the levels between our conditions. So level is the average data points of the data set. So to get a level, you can kind of just, like, I always do my estimation lines. If we were to take like this whole data path and take the average, I think our level line would be somewhere around here. And then for our bottom data path, if we were to take the average, somewhere around here. These don't have to be super clean. If we have good experimental control, we'll see these differences even if your level lines are a bit messy. So if it's okay if it's off like 10, 20% in a lot of cases. So in this one, we see that there's a huge differentiation between our two conditions. So we would say that forward and warm has a clear, consistent effect that it increases the behavior more than this back and cool condition. Now, because we didn't do a comparison to baseline, that's the comparison that we have to make, is that we're comparing it to this back and cool condition. I mentioned earlier that that baseline is optional, but usually you'll have a control condition that is also alternated between. So when we're doing our functional analysis, that's like our play condition. So the play condition serves as the comparison condition for all of our other data paths. So instead of comparing each line to each other, you need to compare each line to the level of the control condition, that play condition. So another just kind of careful thing that you need to do when you're doing experimental analysis work. Cool. So yeah, here's like our statement about experimental control. Forward and warm increases the behavior more than back and cool. And then if we had these values, this y-axis is not labeled, but we could also give the numerical values for that. Okay. What's also cool about looking at the utility of our designs is that we can relate the utility to the features of the designs. So an alternating treatments design is actually really a great design for our severe and dangerous behavior. And these two features are the main reasons why. So first of all, we can rapidly alternate between our conditions. That allows us to test out several different interventions at the very quickly, and we can very quickly identify which one is going to work. And if we were to do that in our withdrawal design, then it's going to take a really long time because we'd have to wait for an appropriate pattern for us to phase change for each of these, and then it would have to be A, B, A, C. We're doing like infinitely more sessions that we would need to do if we were to do an alternating treatment design. Another thing is that baseline condition is optional. So we never have to give our client an opportunity where they're not receiving a treatment just for the experiment's sake. So that makes it really good for severe and dangerous behavior because we can just be like, yep, we think these things could potentially work. Let's test out which one is going to work the best and which one is most feasible to implement for us. Again, we use this design to quickly evaluate the effects of several interventions. And again, that is going to relate to that rapid alternation, that key feature of this design, is that we're rapidly moving between these conditions. We can also use it for learned behavior or irreversible behaviors. It's not always the best design for this, but you can do it. And the reason why is because we're rapidly alternating between these. So they're getting about the same amount of exposure to each intervention. It kind of levels itself out. So for example, first data point, they have no previous learning. Second data point here, they would have experienced the one session of condition 1, but now they're in condition 2. Now in condition 2, they've experienced one session of condition 1 and 2, and now we get this data point. And now so on and so forth. So their experience kind of levels out, is that they were taking data, but they've been exposed to both interventions. So it kind of equals itself out, and that's why we can use it for these learned behaviors or irreversible behaviors. Kind of a trickier concept to understand. Does that make sense for everyone? And how are we feeling alternating treatments designs in general? I think we're almost ready to move on. Jessica S is asking, can we have the other notes for the previous lives? Unfortunately, no. Those are only for people who attend live. So make sure you fill out the form if you want these notes. But if you go on YouTube, you can still watch the full sessions, and all the notes are on screen. So I know it's not quite as convenient, but that's the perks of being here live. All right. Any final thoughts for alternating treatment designs, or else we're going to move on to multiple baseline? All right, I'm ready. Are you guys ready? Give me like a thumbs up or like throw the horns up if in chat if you are ready. Let's see it. Okay. Sweet. Yeah, Elaine, love it. Cool, cool, cool. Sweet. All right, let's move on. We're gonna go to the multiple baseline design. Okay, so we're gonna start off right with a blank here. So, this blank either says a single or multiple interventions. What do you guys think? In a multiple baseline design, can we check one or more than one intervention? What like it? There's like pink hands and like purple peace signs. I'm super into that. Love it. Is that Saturn too with purple rings? If you guys didn't know, purple's my favorite color. I don't know why that matters. But I do love purple. Okay. Well, I think I might have some shocking news for y'all. In a multiple baseline design, we test a single intervention, one intervention, and then we replicate A-B relationships across either different settings, people, or behaviors. So these settings, people, and behaviors, these are not interventions. These are not treatments. These are not independent variables. What are they though? We've got another blank here. So it's a two-word answer. So what do we call these settings, behaviors, or people? They're not independent variables. They are nice. There we go, crew. Rasa, Amanda, Kevin, Elaine, Maria, Carrie Lynn, Flavian. There you go. Shout out to Rasa for starting the trend here, getting people going. This one is our dependent variables. So really important. I feel like a lot of people studying, like they always say like multiple baseline design. We do it across settings, behaviors of people. But like they miss that connection of like, wait, what are those settings, behaviors of people? These are dependent variables. These are behaviors that we're tracking. We're seeing if our intervention affects them. So when we're doing visual analysis for a multiple baseline design, they're really easy to identify because there's not only stacked graphs, but they need to have this staircase pattern. So make sure you're really focused in on the staircase pattern more than the graphs being stacked, because we can have stacked graphs with any of our designs if we're doing multiple participants. So be really careful there. So when we have this staircase pattern, it demonstrates that the DVs have different blank baselines. So what is different about the baselines across our different dependent variables here? They have different one-word answer here. What do you guys think? I like really want to get your name right. Is it Rasa or Reza? Please correct me. Right on track, everybody. Lots of great answers here. I had durations, but I'll totally accept lengths here. So different lengths of our baselines. Our first one here is going to be very short. Then it creates longer and longer and longer as we go down and replicate with our further dependent variables. Awesome. Okay, so in our multiple baseline design, we are replicating our AB relationships across many different, what is this again? AB relationships across different, what goes here? Good. Excellent. Yeah, let's seal the deal here. Excellent. Really nice job, everyone. Again, these are our dependent variables, our DVs. Very nice. Hopefully, if you didn't get that the first time around, that you got it the second time around. Excellent. So here's a graph. And so what we did baseline, low rates of behavior, stabilized out, implemented intervention. We saw a slow climb here. Then we saw it go to between like 90 and 100%, it looks like. This is a generic graph, but that's what it looks like. Very similar patterns in all the rest of our dependent variables here as well. Okay. Couple things about the utility behind multiple baseline designs. They are the most commonly used design, and that's because they're the easiest to run. You can set these up without much effort, and also it's pretty easy to show experimental control on them because you just have to replicate across more dependent variables. I'm gonna take this blank out because we kind of just talk about it. This is our weakest demonstration of experimental control. So reversal, we would say, is our strongest because there's clear relationships with and without. In alternating treatments, there's clear relationships between like intervention 1 and intervention 2. So it still involves the removal of an intervention. So that still allows for good experimental control. But our multiple baseline design is really weak because it never involves a reversal. We never remove the intervention. We only replicate the effects of the intervention across more dependent variables. And then Kevin's asking an interesting question. He's asking if multiple baseline designs if they can or cannot show functional relationships. So I would just say that it's a weak functional relationship rather than no functional relationship. So again, it's just weaker experimental control. We can be less confident in how good these data are, how well this intervention works. But it doesn't mean that we can't demonstrate that it didn't do anything. We can demonstrate that it has a clear effect on several different things. So because of this, because we don't need to do a reversal, we can use this to teach like those irreversible learned behaviors and that's what it seems like we did here because we saw like very high rates of behavior in like the ending data points for all of our different participants here. And we never had to reverse back to a baseline condition. It's a very flexible design. It can be used for a wide variety of behaviors. It doesn't really matter if it's scale acquisition or behavior decrease. It's a pretty flexible design in that way. Though it's not the best design for severe or dangerous behaviors because sometimes we get we are just required to extend a baseline too long. And if we're doing a severe or dangerous behavior, that's something we want to avoid. Alternating treatments is really our best option when we have those dangerous behaviors. Okay, I know a lot of people are always confused about multiple probes, so I threw a multiple probe graph in here kind of last minute for us to go over. So in a multiple probe design, this is a variation of our multiple baseline design. And the difference is that in our baseline and post-intervention phases that we take these probes of data instead of taking continuous data. So the main thing that you want to know is that we only use multiple probe designs for learned or irreversible behaviors. And most multiple probe designs are going to look just like this, very similar patterns. And the reason that we can use probes is because we're doing learned behaviors, and when we don't implement our intervention, we don't expect these behaviors to be learned without it. And then look, when we actually do our intervention, we're not probing here. There's lots of variation in data, so we're taking continuous data while our intervention is going on. And then once they've mastered that skill, then we go back to probes. And the reason why is that because the behavior is not expected to be unlearned after the intervention. So multiple probe is not only a strategy to save time, there's a reason that we can do this, because there's just it's not likely to have any interesting data in these parts of the graph where we're not taking data. So we don't need to, because we don't expect the behavior to change. And we can even think about this as like with our predictions again. We just predict that this trend is going to be 0. And then in our post-intervention, we just think the trend is also going to be 0, just at this high level now. Cool. Yeah, Kevin's asking, why would you probe a learned behavior? And if this would be for a maintenance check, yeah, then that's exactly what it is. We want to make sure that the behavior maintains post-intervention. Exactly. I also had a question. When should we start the next intervention for the multiple baseline design? I think this graph actually didn't quite do it right. So what we usually want to do is we want to see stable data in the first intervention before we implement for intervention 2. So since we had stable data here, I would probably have drawn this line like here or so for this staircase pattern, because that would have been a more appropriate spot, because we had stable data on these 3 data points here. In our first interventions, this would be a more appropriate place to start. Reza's asking, can non-concurrent multiple baseline designs have more than one intervention? No. So non-concurrent just means that the baselines and interventions are occurring at different times. So usually, like, if this were session 1 for all of our participants, then it would be the same exact day for all of those participants. If this was a non-concurrent multiple baseline design, maybe like one participant starts a week later, and we would just either like put some empty space where they didn't do it, or we could just say this is non-concurrent and we'll push the data to make it look cleaner. The only time we'll have a multiple baseline design with multiple interventions is if we have a combination design. So, for example, if we had a multiple baseline with a reversal, then we could have multiple interventions in there. Great question. Great question. All right. Any final thoughts on our multiple baselines, multiple probes? Oh, man, we are almost out of time, but we'll get through changing criterions at least. All right, well, hopefully that is all starting to click. I know some of this stuff is really like dense and deep, so if you're like, yeah, it's like starting to make sense, but I just need a little brush up on more, this recording will be available on YouTube afterwards if you'd like to rewatch it. And again, I'm gonna send you these notes if you filled out that form as well. All right, let's go over changing criterion design. So these are used to gradually change the behavior that's currently in the individual's repertoire. So I'm going to actually just uncover those blanks. It's kind of difficult to ask anyway. We use a goal line or a horizontal. It's also called a horizontal prediction line. It's used to help shape behavior. And this is usually going to be like shaping within a topography because we're changing one response dimension of the behavior. In this example, we're looking at number of math problems completed. So this is going to be shaping across frequency or rate of behavior. So usually with this goal line or the horizontal prediction line, there is going to be some kind of consequence associated with meeting the criteria of the goal line. So for example, it's like if they meet their goal line, there's going to be some kind of reinforcement, or maybe if they don't meet their goal line, there's going to be some kind of punishment or extinction, lack of reinforcement, whatever. With some kind of a consequence associated with meeting or not meeting that goal line. As far as experimental control, this is the trickiest one. Instead of like comparing the levels between our conditions, what we're doing is we're comparing the levels of the behavior to the levels of the goal line. And we have stronger experimental control if the behavior conforms really well to the goal line. So in these examples, I would say that we have really good experimental control because we look at all these data points, they're pretty much right on the goal lines almost every single time. So that's going to be really good experimental control because we're seeing behavior conform really, really well here. If we were to have bad experimental control, we would kind of see these data points be like way off the goal lines. Even if it's a better result clinically, like, yeah, if we can get them to do 12 math problems in session 1 where we only set the criteria for 5, like, yeah, that's a sweet clinical result. But as far as our experiment, that shows that our goal line didn't control its behavior very well. So even if we had a better clinical result, that shows weaker experimental control. And same thing if we had data points that were just like way below. I'm going to delete those because they're messy. But again, that would show no experimental control because the behavior's not lining up with the goal line here. So again, the farther away the data points are from that goal line means that we have less experimental control. And yes, so Kevin's asking if we can use this for decrease or increase, and yeah, we could totally use it for increase or decrease. My favorite example is always just like decreasing Ben & Jerry's consumption. I used to be a fiend, but I'm like good boy now because I'm like trying to get shredded. You can't eat as much Ben & Jerry's as I was eating if you're trying to get shredded, unfortunately. But yeah, you can use that to gradually decrease as well. Let's say I was eating like 4 pints a week before. I don't think I got that bad, but if I was at 4, then I could decrease that to 3, set some kind of reinforcement for meeting 3 or under. As I progress, lower that to 2, 1, eventually 0, and have consequences associated with that the whole way. All right. I wasn't sure how long this was going to take. I did want to go over a couple of these research article graphs, but I think what we'll do is we'll start Thursday's session by going through some of these research article graphs and really like breaking them down, the components, and hopefully like this session today prepares you for looking at the graphs on Thursday. So that Thursday is going to be at 9 p.m. Eastern time. So it's going to be that's going to be at 8 p.m. Eastern time. So that will be 5 Pacific, 6 Mountain, 7 Central. Interesting. Kevin, you didn't share that, but interesting. Well, thank you guys so much for coming. Just a couple last minute reminders. If you do want to receive the notes for this session, make sure that you fill out that form and drop your feedback in there. On Thursday, we're going to do this again. We're going to start with the graphs, and then we're going to go for free-for-all topics. So if you're there early, you can get your topic in, and I will review it with you. Hopefully this session was really helpful and awesome. I felt like it's a pretty good big overview of experimental design, bigger than we've done before. Hopefully, yeah, thank you guys so much. I really appreciate all of your interaction tonight and being here with me. This is so far our most popular stream ever, so love breaking those numbers. Thank you guys so much for helping me do that. And again, if you do like my style, you do like my teaching, or you just want to get this free 25-question mock, make sure you check out my shop at understandingbehavior.shop. Also, I have a link tree that I will drop in the comments as well. So feel free to check that out. I post questions on Facebook and Instagram pretty frequently, practice questions, and a bunch of other jazz. If you want to get notifications about like when these study halls are occurring, that's great too. But yeah, I think we're gonna end this session on that note. Again, thank you guys so much for being here. It means the world to me. I hope you guys have a great night. I will send these notes out likely in the morning, so watch out for your email then. And I hope to see you guys Thursday. Let's do it again in 2 days. All right. Thank you so much. Take care. Bye.